Hi, I'm going to talk to you today about the physical geography of mountains and mountain building, and also some of the processes that go on in these mountains. Now, I am in the Alps, and I'm skiing at the Porte du Soleil ski area near Morzine. You can tell this from the brilliant scenery around me. Oh no, you can't. Actually, there's a wall behind me, and the reason you can't see these beautiful mountains around me is because they're not here, because I'm not skiing. I'm supposed to be skiing, but actually I'm still in Chelmsford because the Omicron COVID variant has hit and I'm not allowed into France. There we go. Okay, the Alps, which we can't see, stretch 750 miles across 8 nations. Now, from west to east, we have France, Switzerland, Monaco, Italy, Liechtenstein, Austria, Germany, and Slovenia. Of these, the countries with the greatest alpine territory are Austria and Italy, each of which has about 30% of their country being within the Alps. Now, the highest peak in the Alps is Mont Blanc, which is 4,810 metres or 15,780 feet. For some context, Mount Everest, which is the highest mountain in the world, is nearly twice as big at 8,849 metres. So how did these mountains get here? And where did they come from? This was a mystery for a long time, and through the 18th century and the 19th century, the idea of geosynclines was a very popular theory. The idea was that sediment was eroded from land, it fell into the sea, and was then somehow uplifted to form mountains. Now, this belief came about because actually people were able to scientists observed the folded layers of the rocks in the mountains. So the idea of geosynclines came from that. It wasn't a bad idea, but it wasn't quite right. It wasn't really backed up by the understanding of the mechanism behind this, and what we now understand to be plate tectonics. Many scientists thought that the sediments were uplifted as land masses were pulled closer together as the Earth cooled and contracted, which we simply now think isn't right. Those, though, who built on the work of Alfred Wegener, who worked during the early 20th century, he came up with the idea of continental drift. The people that built on that work discovered plate tectonics in the mid-20th century, and therefore this mechanism for moving land masses around, which we now theorise is about convection currents in the mantle working and ridge push and slab pull processes. Now, the Alps were made when the African plate and the Eurasian plates collided. The ocean that existed between them has now disappeared. It's often referred to as the Alpine Tethys Sea, or Alpine Tethys Ocean. The Mediterranean Sea, by the way, is more recent and not related to the creation of the Alps. The rocks in the Alps are quite complex. There are lots of sedimentary rocks which were uplifted from the seafloor. Some of these have metamorphosed, and there's some rocks which are the remnants of ancient volcanic eruptions. Evidence is a bit mixed as to whether the Alps are still being uplifted and growing by tectonic forces. Perhaps they are growing a little bit. Perhaps they're growing at different rates in different places, that's more likely. But what we can be sure of, though, is that they are eroding and weathering. They're being denuded from the top. The effects of water and ice and wind and temperature fluctuations and so on, which of course further complicates the idea of any growth rate there may be. These changes, though, are generally very slow. Perhaps some faster change could happen into the future. Climate modelling suggests that snowfall, snowpack, glaciation and river runoff might be affected in the coming years. The physical landscape and the ways of life and the ecology of the mountains might alter.